Hey everyone, and welcome. Have you ever built a React component, passed it some data, and then had it just break? All because you sent a string when it was expecting a number? Yeah, we've all been there. Today, we're going to dive into how to stop that from ever happening again by combining the awesome power of React with the safety of TypeScript. All right, let's get into it.
So here's the plan. We're going to start with the big why. Why even bother with this? Then we'll get our hands dirty and build a component step by step. We'll start by typing its props, then give it some memory with typed state, and finally make it interactive by handling user events. All of it the type-safe way. Okay, first things first. Why add TypeScript to your React project? Well, the whole idea is actually pretty simple, but it is incredibly powerful. It's all about catching bugs before they happen, right in your editor, not when a user is clicking around your app. I mean, just think about it. What if your code editor could act like a helpful co-pilot, tapping you on the shoulder the very instant you make a mistake? That's exactly what TypeScript is. It's not about making things more complicated. It's about giving yourself a safety net that catches all those common, annoying errors automatically.
All right, let's start building. The most fundamental way we pass data to a component is through props. And when you use TypeScript, you can think of typing your props as creating a really clear contract that spells out exactly what your component needs to do its job.
So check this out. We're using something called an interface to create a blueprint for our props. This little block of code says two things. One, our component must get a name prop, and it has to be a string. Two, it might get an enthusiasm level. And see that little question mark? That's what makes it optional. But if it is provided, it has to be a number. So what happens if we break that contract? We've all done this, right? You try to use a component, but you forget one of the required props. In plain JavaScript, this is where you start getting those weird runtime bugs. And boom, this is the magic moment. Before you even save the file or look at your browser, TypeScript steps in and gives you this perfectly clear error. It tells you exactly what's wrong. Hey, you're missing the name property. The bug is squashed before it was even born. And the fix? Well, it's pretty much exactly what the error message told us to do. We just provide the name prop, and just like that, TypeScript is happy. It's like having a guide, making sure you use your own components the right way, every single time. But it's not just about missing props. It's also about passing the wrong kind of data. Here, we're trying to pass the enthusiasm level as a string. See the quotes are on the 3? And again, TypeScript catches it instantly. It prevents that classic bug where your code tries to do math with a string and everything just breaks. And hey, it doesn't matter if you're using modern function components or if you're working with older class components. The principle is exactly the same. You define that props interface, you apply it, and you get all that awesome type safety. The syntax is a little different, sure, but the benefit is identical. Okay, so props are all about data coming into a component. But what about the data a component manages all by itself? That's where state comes in. You can think of state as the component's own internal memory. To put it simply, state is just the private data that a component holds onto. It's the stuff that can change over time, based on user interaction or other events. And whenever that state changes, React is smart enough to know it needs to re-render the component to show the latest updates. And no surprise here, we're going to do the exact same thing we did with props. We start by defining a contract. Our state interface here is super simple. It just says that this component is going to keep track of one piece of data, current enthusiasm, and that value has to be a number. Now, if you're using class components, you'll see these funny angle brackets. Don't let them scare you. It's really straightforward. The first thing you put inside is your props type, and the second is your state type. If your component doesn't have props, you can just use an empty object. Or if it doesn't have state, you can just leave the second one out. Simple as that. So when you put it all together, it's really just a simple 4-step recipe. First, you define your state interface. Second, you tell your component class about it. Third, you give it a starting value. And fourth, you create methods that can safely update that state. All right, our component has its data, it has its memory. Now let's make it do something. The final piece of the puzzle is making it interactive. Let's see how TypeScript helps us handle things like button clicks in a completely safe way. You know, when you handle an event in React, you're not actually getting the raw native event from the browser. Instead, React gives you this thing called a synthetic event. It's basically a wrapper that smooths out all the weird differences between browsers. And for us, the most important part is that it's something we can use a type for. And this is where the real payoff comes in. Just by adding SyntheticEvent to our event handler, We've just unlocked a superpower in our code editor. Now, when you're inside this function and you type event followed by a dot, your editor will pop up a list of all the valid properties on that event. No more guessing. So why do this? It really boils down to two huge wins. First, you get that amazing autocomplete, which makes you code faster. And second, you get type safety. It literally stops you from making a typo or trying to access a property that doesn't even exist on that particular event. It's another class of bugs, just gone.
Okay, let's take a breath. We've built this component from the ground up. We added contracts for its props, for its internal state, and even for its user interactions. Now let's just step back for a second and look at the massive advantage all this work gives us.
Think about what TypeScript just did for us. It was like our coding co-pilot the whole way through. It stopped us from shipping bugs by checking our props. It made our components self-documenting so any developer can look at it and know exactly how to use it. It made sure our state never got into some weird, unexpected shape. And it made handling user interactions faster and way safer.
By defining these clear contracts for everything our components do, we're basically moving from hoping our code works to knowing it will. So really, the only question left is, are you ready to start building some truly unbreakable React apps? Thanks for joining me.